Hi, hello everyone. Thank you for being patient. There was a hiccup on my computer with permissions on Mac, so I changed that. Okay, so thank you for joining us. We'll be covering some concepts and features of the Yank-Bush standard today. I'll be doing the presentation, and I have my colleagues here with me, Greg, Wei, and others who will be able to answer questions, should you have any questions, via the Q&A section of this window. So you'll find that on the right side. That should be pretty obvious. At the end, we'll reserve a few minutes for any other remaining unanswered questions. Okay. I'll see if I can make this a little bit bigger. All right. So the goal here of this workshop is to introduce Yank-Bush as well as the different RFCs that are involved in this standard. And at the end of the workshop, I'll be showing a demo of the Yank-Bush support in Conf-D. So part of it is going to be RFC oriented. The second part is going to be Conf-D support of Yank-Bush. With regards to the RFC, just a couple of things. I'm not going to cover everything in the RFC. So there are certain things like the error handling, subscription, change notifications. Those are notifications for subscription events. So those will not be covered, but we'll cover the main part of the RFC. So as you know, it's defined in our RFC 8641, subscription to Yang notifications for data store updates. And by the way, subscription to notifications existed way before, and I'll show you what the difference was between the previous RFCs and this RFC. The goal of Yank-Bush is to allow controllers, orchestrators, NMS system to monitor network elements, but using a push approach as opposed to a pull approach. It's used for telemetry data, for streaming telemetry data, as well as for configuration data update notifications and operational, basically any data that you would like to notify a receiver about, either for a change or just periodically notify them about the data that you support on your system for any kind of events. Yank-Bush can be used for that purpose. And it enables automation at scale and intent-based networking because there is more data that is interesting to collect. And I'll talk a little bit more about that later. So why a new why a push, basically, as opposed to a pull model? There are with the pull model, traditionally SNMP GET requests were used. netconf GET RPC could be used as well for pulling devices for data that you are interested in. Also, CLI scripts were used to collect that data. So those are examples of a pull model. They are typically initiated from a local central location, and these requests are periodic or whenever a controller needs to get that data. So there are obviously some limitations with polling. These limitations are more important in my view. First one is that there is no knowledge of when the data has changed. So there is some important data that would give you an insight into how your devices are behaving in the network, or how the whole network service is behaving So that data, if you are pulling it periodically, you might be missing some important changes to that data. So that's the telemetry data that is used or is part of the automation and intent-based networking architecture, and is very important for controllers to get that data so that they can react quickly if some thresholds are crossed or things like that. So critical changes in the network. So this is basically that I touched upon, which is very important to be detected on time and not wait for the period to finish. So that renders a pull model not fit for telemetry. So some more of the why. As I said earlier, traditionally, protocols like SNMP were used to pull the data. And as you know, SNMP uses UDP. So there is a risk for missing requests by the network elements that you have. So requests can be lost or delayed, and that can lead to inaccurate data. Also, the polling means sending the same request multiple times. And as you know, you might have in your network multiple collectors, which can increase the resources needed for this operation, for the network elements to respond. So that's one of these are limitations of the SNMP protocol for polling the data from a network. NetConf get RPCs are obviously more reliable since NetConf sits on top of SSH or TCP. But they are also resource intensive because every time we are requiring the client or the receiver of the data to initiate the polling. So polling now doesn't work for telemetry with large data to collect. There is a need to be notified only when some data changes occur, and hence reducing the load on the network. There is an RFC actually that, if you are interested in, that details the requirements for a new method to collect data from devices. I can show you the RFC number later, but if you are interested, you can also find those details in RFC 8641. The solution to all of these limitations are automatic updates. So automatic updates just means that a receiver will once subscribe to the data that they are interested in, and then let the publisher or the network element send that data automatically whenever there are updates or whenever certain conditions occur. So we'll look into that in more details later on. So how does it work? If you want to understand Yank push fully, so there are 3 RFCs that you could start by looking at. Actually, there are 4 RFCs, more than 4. There are 5 RFCs. The first one, it's not mentioned here. It's about NetConf notifications support. That RFC is great for you to understand how NetConf notifications work in general. So that's not NetConf specific. The next RFCs are 8639, which is a subscription to Yank notifications. So these first 3 RFCs mentioned here contribute to Yank push. It's not Yank push RFC. The last one is the Yank push RFC. So we will talk about all these RFCs since they build on top of each other, and understanding them is needed to understand Yank push. So the first one, subscription to Yank notifications, brings about a new data model that is used to model subscriptions. Also, some RPCs that allow a collector to subscribe to notifications. The next 2 ones are specific to the protocols NetConf and RESTConf. And the last one, obviously, is Yank push. We'll talk about that in more details. So Yank push is also described as a subscription service. So you are, by supporting Yang push, you are providing a subscription service to remote collectors or applications that are interested in all kinds of data in your data store. So you have here a subscriber who will subscribe to data changes in a publisher, specifying conditions such as whether they want subscription to be periodic or on change, only when data has changed. So when subscribers subscribe to receive data, they specify the frequency and conditions. They also have capability of managing the subscription per the RFC. So if you are supporting the RFC, you need to support those capabilities for subscription management. The publisher and network elements will then take care of pushing the data to the subscribed applications. This way, it's more flexible and effective. You are reducing a lot of load on the system, and you are also enabling certain applications to enabling some intelligence on the subscriber side to allow applications to pick and choose specific things that they are interested in or that they can act on. So I mentioned an RFC earlier. The first RFC was specified in 5277. It was made standard on July 2008. NetConf event notifications. Sorry, I need to reduce the window for a little bit, just short time here. So NetConf notifications were defined in 5277. In 2008, Yang didn't exist at that time. NetConf in this RFC is the transport. RESTConf also did not exist. In this RFC, create subscription, or RPC, was introduced, and create subscription is a way for a collector to subscribe to streams on a server, on a NetConf server. So there is a notion here introduced of streams that I'll explain a little bit later. But at this time, you were able to receive asynchronous notifications from a NetConf server. So somewhat, it's a push method as well, but for streams of data. So the NetConf server maintains this stream information, and it is a client can basically see what streams are configured on the server, and they can subscribe to those streams. The issues and limitations, as I mentioned briefly, are tied to the NetConf protocol. Actually, the RFC is tied to the NetConf protocol, so it's not general. You cannot apply it to other things like RESTConf, gRPC, if you want to, or any other future protocol. So they needed a more generic way or more generic standard that can apply to all these protocols. It's also predated Yang 1, which is the first version of Yang, which means that create subscription and the data that is described, the RPC and the notifications that are described in this RFC are not modeled in Yang. So there isn't a standard Yang model that corresponds to those. And also no NMDA support. Of course, we're subscribing to streams, not to data stores with create subscription. So a little bit about event streams. What are they? Event streams are simply logical entities defined by the server, the NetConf server, and provide a subscriber can view these event streams. In the case of confd, they are configured in confd.conf. You can do a get operation from a NetConf client to see these streams. A confd application would then register. So when we say confd application, this is an application that's running southbound of confd. So the typical workflow, it registers for sending on a specific stream using confd register notification stream. and then it gets a context. So whenever the application would like to send a notification for that context, use another API, conf notification send, specifies the context and the data for that notification that it wants to send. And on the other side, subscribers subscribe to streams. So they'll get, if there is a subscription that Confi tracks for specific stream, the Confi takes care of sending those notifications. So it's a pretty simple concept. Now this is more becomes more important with RFC 8639. I think this is a really big jump. And this RFC is called subscription to Yang notifications. It defines a superset of the subscription capabilities that are defined in the previous RFC. And of course, it comes with a new Yang model that we'll take a look at later, that defines several new RPCs that were added to the standard for subscription handling. So it is also another advantage of this RFC, and another thing that it brings is that it is agnostic to the transport protocol. So it applies to netconf, applies to restconf, and there are RFCs that I mentioned earlier specific to the protocol, either netconf or restconf. All right, and one thing to keep in mind is that this RFC can coexist, the RFC support can coexist with RFC 5277, create subscription, with the limitation that you can only use either the create subscription in this RFC or the new RFCs to establish a subscription that's are defined. You cannot mix and match, basically. They both, up till now, you can only subscribe to streams. We don't subscribe to data store nodes yet. That comes with Yang push. So that's the difference between this RFC and Yang push. So two types of subscriptions were defined in this RFC. And it's very important to understand the difference here, although in ConfD we only support one of these. So there are two types. First one is the configured subscriptions. So this allows a client to configure subscriptions in the configuration database. Those will persist. Basically, their lifetime will be the lifetime of the configuration. If you want to get rid of them, you delete them. So this is a feature that's not supporting ConfD. It's optional as well in the RFC. So it's not tied to the connection to a session. The second type of subscription is dynamic subscription. So this is the type of subscription that's supported also since July 2008 with the first netconf notifications RFC. It is dynamic subscription, meaning that a subscription can be established once a subscriber opens a session, netconf session or restconf session, and then it goes away when the session goes away. So it's not persisting on the server. So yeah, it can also, the dynamic subscription can also be modified during the lifetime of the subscription. So when the session, of course, the session needs to be open, and then you can, there are new RPCs that are introduced in this RFC that allow you to make changes to the subscription. There are some limitations. For example, you cannot change the type of the subscription from periodic to on change. And that's for push standard. So these are the new RPCs that are defined. Established subscription, this is the equivalent, somewhat equivalent to the create subscription that was defined in 5277. It specifies a stream still and can specify a filter as well. So keep in mind these four RPCs. Modify subscription allows you to modify subscription during the session. You can change the stream, could change which stream you want to subscribe to. You can also change the filters that you used. Delete subscription also must be on the same transport session as established subscription. allows you to delete your subscription. Kill subscription, this can be from somewhere else. So if you lost your client for some reason, session is still open, or you lost access for some reason, then you are able to kill some subscriptions. All right, so Yang model for subscribed notifications. So this one is the one that was introduced in 8639. The publishers must indicate support of IETF-subscribe-notifications.yang in the Yang library. So this is the model where those RPCs we just saw are defined. In confd, you can find it under source confd Yang. And you can easily view this Yang model using Pyang. If you used Pyang before, it's pretty straightforward to understand this Yang model using a visual tree instead of text. It's also, you can also create an HTML version of it. We'll take a look at this one in a little bit. Okay. On the server, on the netconf server, RESTconf server, anyway, in confd, we support the data for the configuration for subscription. So you are able to see the subscription information on the server and see all the details of each subscription there. So this is the tree of the subscription data on the server. The second RFC that I noted earlier is specific to netconf. So netconf server can support both RFCs 5277 and 8639. Create subscription and establish subscription, as I mentioned, can't mix on the same session. You can still, use one on a different session if you are interested in using create subscription or the new established subscription that has more capabilities. When a netconf session ends, then any subscription on that session must end. And by the way, the coexistence of both create subscription and established subscription, I believe, is for backward compatibility issues. So, okay, so the subscription is tied to the session. When it ends, then your subscription ends. So this I talked a little bit more also about modify subscription and delete subscription, what they do, and the only difference between those and the kill subscription is that they have to be on the same session, netconf session. So this is, if you look at this RFC, this is what it will be talking about mostly. There are some more details as well. So if you want to learn more about 8639 and this RFC, they were added in the support for them was added in confd 7.3, and we have an example, really good example, under the examples folder of confd. So that's a good place to start if you would like to play a little bit with streams and also understand the established subscription, the new RPCs that are added, because those are the same RPCs that are going to be used as well in Yang push. All right, so 8641. So this is the Yang push RFC, which is specific to data store nodes updates. So data store updates as opposed to stream updates. So up till now, all the subscriptions and notifications were tied to a stream. From Yang push onward, you can actually still use streams, but Yang push has to do more with data stores, data store nodes. So you are able, in this case, the application is able to subscribe directly to certain nodes in the tree. Just 1 second, I got a strange message here. So I'll show you the Yang tree for what's been added in Yang push. This way you can clearly see the difference between the two RFCs, 8639 and 8641. Okay, just need to launch my terminal, see if I, oops. All right, I think I still have still have an issue with my sharing. Let's see. I can share from this. Greg, are you there?
I'm here. Sorry.
Oh, okay. Yeah, no problem. No problem. I have some issues with sharing the terminal. I was wondering if I don't know if you could or not. I have a permission issues on.
Sure. What did you want me to do?
Could you do you have access to the terminal? Could you share the yank push example?
You want me to run it? You mean?
Yeah, is that possible?
Yeah. Just give me a second. Why don't you
take your time? It's not now. I haven't finished yet.
Your presentation, and I'll set that up.
Sounds good. Thank you. All right, so we got some questions here. I'm gonna pause before I dive deeper into yank push. I'm gonna pause and look at the questions. So is the netcom subtree filter supported? What's the implication on yank notifications? Good question. The subtree filter, I'll talk about that a bit later, but the subtree filter here is supported for netconf get RPC for the other RPCs. In the context of yank push, the filtering, because yank push also supports filtering, that's not supported. What we support is the XPath filter. RFC 8641 that we're looking at right now specifies that a server should support one or the other. Of course, both can support both, but if you don't support one of them is optional, basically. Either one can be optional as long as you support the other one. So either XPath or subtree. And we'll take a look at that later. What's the difference between streams and data store? Could you please illustrate? Yes, good question. So data stores are per NMDA is a definition of for example, there is the running data store that holds configuration, intended data store, operational data store. There are several data stores in the NMDA RFC that I recommend taking a look at. So those are the data stores. They are rendered from, in the case of confd, they are based on the schema that's derivated from the Yang models. So they map to Yang models. Streams are just some logical entities, just a string, right? That's that the server uses to identify something called streams. They are defined in the RFCs that I mentioned earlier, 5277. You can take a look at that RFC. But they are just entities. They don't map. They don't get stored in. They don't map to data stores. Basically, they can be stored for a get operation for to view what streams are supported by the server, but they're just entities that help map notifications to subscriptions. Let's put it that way. Okay, I think I'll continue for now because I think I see that all the questions are being answered as we go. Okay. So yank push, what was introduced with yank push also are conditions that trigger the updates. So there are two conditions, either that will trigger the updates. Those are called conditions, and they're periodic type of updates, and there is on change type of updates. I think this is a clear, self-explanatory for the condition. So we'll take a look at those later. Okay. So this is a snippet of the IETF subscribe notifications Yang model. So again, this model was born with 8639 prior to Yang push. And there were, with Yang push, what Yang push did is it augmented this Yang model by adding a few more characteristics actually of the RPCs, as well as the filters. For example, the selection filter node was added in Yang push. This allows you to select which whether you use a data store subtree filter, basically which nodes you want to subscribe to, or using an XPath filter. So as I said just now, we only support data store XPath filter. There is also a subscriptions node, like I showed earlier. There's a subscription node that shows you all the information about the subscription. For Yang push, it was also augmented with a data store node that will show you also some more details on that. So this is under subscription. It also shows you whether the subscription is periodic or on change. For periodic subscriptions, as you can see here, I'll show you an example later on. For periodic subscriptions, a client can provide a period as well as an anchor time. This is optional. The second one is optional. But basically, the subscriber will specify the period that they want to use, or the frequency of getting those notifications, and an anchor time. Anchor time basically is just time to say, for a way to say, I want something 10 minutes after, you know, the 5 o'clock, for example, or and start always 10 minutes after a certain time. So you can specify it that way. And also on change supports other parameters like dampening period, sync on start. Dampening period for the subscription means the subscriber will specify a certain time that they don't want to receive notifications on. And that's very useful in the case of objects in the data store that keep changing a lot, or maybe sometimes they change, they keep flapping their value, or for example, temperature. If you're tracking it at with more precision, so that can be useful for a subscriber not to be flooded with those notifications. Sync on start just allows a subscriber who is subscribing for on-change notifications to synchronize first with what's on the device, and then start receiving on-change notifications. So this is the first RPC for Yang push, established subscription. The inputs to the established subscription can either be a stream, like I mentioned, there is support for streams that predates Yang push, and also data store. So this is the first interaction with the netconf server when you are trying to create subscriptions. So you send an established subscription RPC. That will, then you can select which data store you want to subscribe to, whether it's a running or an operational data store. It can be actually any data store per the definition of this Yang model. And you can also specify certain filters using data store XPath filter. As I said, data store subtree filter is not supported, but the XPath is. And then the update trigger is whether it's a periodic or on change. So what would trigger a notification to be sent from the server? If it's time tied to a certain time, which is periodic, then you specify it during your established subscription. Also, whether it's an on change and you're only interested in data if it changes on the server. So yeah, so and the output you get is the replay start time revision. That's optional output because this is for a replay. If you want to replay previous, I guess, missed notifications in that case. There's also the modify subscription. So you are allowed to modify, per the RFC, you can modify the subscription that you established already instead of deleting it. So you can just modify certain things. There are certain things that are not supported in conf.d for modification, which is the on change. If basically the trigger, the update trigger, whether it's on change or periodic, you cannot change it to the other value. So when do you use periodic and when do you use on change subscriptions? There is data that is more appropriate for periodic changes, and that data is, for example, counters, measures, things that change very frequently. You don't want to be getting those changes every time they happen. And the second type of data that you can classify as states, configuration, that data that doesn't change too frequently, so that you can use an on-chain subscription for. So this is something that you need to also keep in mind when you're supporting Yank Push, and identify the data that you want to support for on-change and periodic. One thing that I didn't mention earlier, this subscription model or subscription service. The subscription service is actually a negotiation between a client and the server. So the client sends originally an established subscription to the server and specifies some conditions, right? I want, for example, a periodic subscription. I want to establish a periodic subscription on this data, or I want to establish an on-chain subscription on this other data, and I want this frequency from the server. So I want you to, actually the frequency applies for periodic, but the on-change or periodic, in any case, the server doesn't have to honor that request if it can't. So in that case, there are means in the RFC for the server to return some the error, first of all, to tell you that no, it cannot honor the subscription, but it can also return some hints on what you need to change in your subscription request. It's a negotiation. Now the clients, after receiving those hints, can decide whether yes, that's fine, I can deal with that. And just to give you an example, if it's periodic subscription you want, and you specify a period that's too short, and at the same time you specify a large amount of data that you want to receive notifications for. So in that case, the server might say, no, I cannot basically send you all of this data in this short period of time, and just keep on doing that. So that can be an error. Good question. Pull very close to periodic, because you can actually it's very close, the pull method as opposed to the push method for periodic subscriptions. They are very, very close, but there is, as we said earlier, there are limitations of the pull, because when you send a request, there are more resources involved. So from the resource perspective, the Yank Push periodic subscriptions is better. So because that allows the client to just subscribe once and let the server handle the sending out the notifications. And also with the RFC, the push RFC Yank Push, it specifies certain things. It made it more of a service, subscription service. So and also negotiable terms between the client and the server, as long as you support those error messages, hints that the server can send, and so on. So periodic subscriptions. You can specify the anchor time. It's optional. It's a reference point in time, as I mentioned earlier. It's just used to calculate when the periodic updates need to be sent. So this is an example of an established subscription where we specify here the data store, operational data store we're targeting. Also the filter, the data store XPath filter. So within that, our filter right now is simple /if interfaces. So basically here we're subscribing for all the periodically for the data that's under /interfaces that resides in the operational data store. And we're specifying a period. So 100, this is in the unit here is centiseconds. So it's 1 second. This is 1 second, basically. So on change subscription, you receive updates only when a change is detected. So that change can be, it can be a configuration, can be an operational data change on the server. So you only receive notifications when those changes happen. There is a dampening period that you can specify. It's optional, but you can specify a dampening period, and you decide that based on the data that you want to be notified about, if that data can flap, like an interface flapping or temperature, something like that. That can flap a lot. So you don't want to be receiving those. You can also specify a change type. So this gets more interesting now because you can specify whether you want to be notified only when objects are created in the database, or you want to be specified only when objects are deleted, or a combination of both, or when values change. So you can specify those things for on-chain subscriptions. It's useful for data that changes infrequently, as I mentioned earlier, but the requirement here is that notifications need to be sent quickly when changes occur. So this typically applies for those metrics that you have in the network that will really decide or impact a service, and you want to act on those as quickly as possible. So that's why you would require the notification to be sent as quickly as possible. But imagine you have a big network, a lot of network elements in your network. So that's when this becomes very important to support. You will be receiving those almost real time. Well, at least they will be sent right away. So that's why you can make changes to your configuration, for example, or make some other changes that are required to maintain the service level that you want to assure. So that's just an example, not all of it. Yang model for Yang push subscribed notifications is defined in ITF Yang push.yang. And as I said earlier, this Yang model brings one more RPC and also augments IETF subscribe notifications.yang in you can find this in the source folder under confd under Yang. Again, for these you can visualize the information using a tree filter. Streaming updates. So this part deals with the notification types that your clients can receive, the subscriber can receive. There are two types of notifications. There's a push update notification, and there is a push change update notification. The push update notification is used primarily for periodic subscriptions. It can also be used for on-chain subscriptions, the reason why it would be used for on-chain subscriptions is when you are establishing an on-chain subscriptions, you need to sync right with the node first. Push update notification will be sent to you with the data that you are interested in for on-chain notifications. And after that, you will only receive push change update notifications for any changes. So that's the case for on change. You can also get a push update notification when you are subscribing to on change notifications if you want to resync with the device. So that's the second case where you would receive push update. Push change update notifications, it's only for on-change subscriptions. And we are in our example, Conf example, I don't know if we're going to have time to look at that. It's straightforward example. There's a README file. And what it does basically is it runs the established subscription RPC towards Conf and does that for a periodic and on-change update subscription. So I recommend looking at the example in more details, so you can understand how some of the callbacks are implemented southbound of Conf. So on-chain subscription on operational. So this is something to note on when you are subscribing to operational data for the on-change. So as you know, in Conf, for example, operational data is provided by applications that run southbound of Conf using the data provider API. So when you do a get, for example, from northbound, Conf will trigger those callbacks to be called, and the data provider returns that data, right? So data provider's role for the on-chain subscription operational, the push of notifications is up to the data providers, because they are the ones that have the master database for operational data. So they are the ones that need to be pushing those notifications. But in order for data providers to understand, yes, there is a subscription on that data, we needed to add some more APIs, right? So we have an experimental data provider API in Conf as of Conf 7.5. And in the example, you'll be able to see those APIs, how they are used. It works. It's called experimental for the reason that it might change in a non-backward compatible way, depending on how this feature is being used in the field, depending on customer requirements and so on. It's experimental, but it works you can take a look at the example and run it. So the subscription create and delete callbacks, in this case, they need to be registered by the data provider. So this implementation for the create and delete is the responsibility of the data provider. A push on-chain notification callback needs to be called by the data provider as well. So this is really straightforward since the data is owned by the data provider. Yeah, so in the case of configuration, if you are subscribing to on-chain for configuration and the configuration is stored in CDB, Conf takes care of all of this. You can actually abstract this concept and put CDB as a data provider as well. So the same protocol applies. So I want to point you to the example that we have under examples of Conf called netconf and push. It has both of these concepts illustrated on change and periodic subscription. Now, some of the things I wanted to note for as far as the limitations go in Conf 7.5 for this feature. Configured subscription as I mentioned earlier, is not supported. The data provider API for on-change subscriptions to operational data store might change in a non-backward compatible way. The modify subscription is not supported for changing the type of the subscription, basically changing it from periodic to on-change or vice versa. Again, the data store subtree filter is not supported in Conf. And there are also some limitations on monitoring of subscriptions. You can find more details in the user guide for those. But there are the data store subtree filter is not supported, I believe, because of the any data, which Conf doesn't support, I believe. Also, per the RFC, these are not mandatory to be supported by a netconf server. So still compliance with the RFC in this case. But they are just, is important to know what limitations are in there. So here I have some resources that I'll be sharing with everyone. You can, basically the RFCs, you can access those anytime. But we have an Yang push application notes on TAILF websites that you can take a look at. All right, so with that, I think we're gonna end it here. With regards to the example, I actually was going to show some of the payloads and established subscription, how it's sent, and the notifications, but that's something that's straightforward. I prefer to talk to the slides more than to show something that you can run on your own, and that could be a good way to as a follow-up for you to go and run the examples and try to understand what we discussed today. So, Wei, are there any questions that are pending still?
I believe there are a few. You can look at the unanswered ones.
All right. Okay. Oh, there's a lot of questions here. All right. So the streaming updates on this slide means they use streams, which is different from data store notifications. Yes. So streams is another is one of the options in a choice statement. When you establish a subscription, you can establish it either for a stream or for a data store update. So yeah, I think whenever there's a new question, I lose the previous one.
There are three more at the end. You can scroll to the bottom.
Okay.
The last three.
Yeah.
I didn't get to those. Yeah.
Yeah. NetsConf Yang is well supported in SP platforms, but not in enterprise or data center switching. Any plan to be uniform across Cisco all product lines? Yeah, we're heading there. They are supported in actually in some data center switching, some switching products, not only for service provider platforms, but it is an ongoing effort to support more Yang models, especially standard Yang models. Is that true? Pat's attributes from NetsConf Yang must be in the first place available in show tag. I'm not sure I understand this question. Wei, do you understand this one?
I don't either.
Okay, could you please clarify, Shiji? Can we get the pointers on the last slide? Yes, of course. I'm going to send you the slides as well as the recording after, maybe today or tomorrow, depending on when the recording is available. So there's just one remaining question here that is not clear. Is that true? Pat's attributes from NetsConf Yang must be in the first place available in show. Oh, maybe you mean.
Yeah, I don't know if that's in the show command itself, but yeah, I mean, basically, I mean, it has to be modeled in Yang, right? And that can be distinct from what's available via the CLI. So,
Right. And there are certain things that are available, like subscriptions. They are available in the show command. But it's not must be. The question is, it doesn't apply actually to conf.d, because whatever is supported in Yang can be immediately seen via either show commands in CLI, or it's rendered at the same time. So if you allow permissions for users to view that data via CLI, then yes, they'll be supported in CLI at the same time as netconf or any other node-bound interface. So I'm gonna scroll up a little bit just in case there's a question that wasn't answered, but I see your answers, Wei. Hopefully that's
Well, so Shiji kind of
There's one,
expand,
yeah, there's one question added at the end.
expanded a little bit. So with the thing about NetConf is we support the NACM rules, the net access control models. So you can restrict access to certain data in your Yang models. So because everything's session oriented, you have to provide, some kind of username that's going to be associated with group accesses, and that all fits together to kind of control what data can be seen and what data can't be seen. So, sorry, go ahead.
Yep, thanks, Greg. There's another question. Can you explain how Yang push is more performant, more effective than UDP SNMP approach? I think this question is mostly to do with the payload, since it's in XML. We're not talking about performance in this case. We're talking about effectiveness. So when I talked about SNMP limitations earlier, I mentioned the effectiveness problem with regards to the protocol used by SNMP, which is UDP, right? So you can be getting requests, because with UDP you can be getting requests that are missed or lost in the network, and in that case, your subscriber wouldn't be getting the data that they're requesting, also the delays as well. Now with the performance, yes, XML adds more data there, right? I don't know if you have something to add, Greg, to that.
In terms of what, performance or?
Right, payload.
Yeah, right. So, I mean, Nabil mentioned earlier that 8639 was written to be sort of transport agnostic. One of the purposes would be at some point possibly that a more efficient encoding, like a gRPC with protobufs, or some kind of more dense encoding might be introduced. But yeah, I mean, currently what we do support is, and what you see just generally is, an XML and possibly, JSON style, if you have RESTconf. There is some work within the working groups, I think, to define other mechanisms for supporting Yang push, specifically with the subscribe notifications, so as opposed to dynamic. But that's ongoing work within the working group right now.
Yeah, thanks. Yeah. So keep in mind, Yang push is not only specific to NetConf. It's also, RESTconf, gRPC, and so on. I mean, you can add other protocols. I think the question is more about NetConf notifications here. Okay, so with that, thank you for staying till the end. I'll be sharing everything I presented today, and also point out the resources and the examples in Conf-D. Thank you. Thank you, Wei. Thanks, Greg.
Sure.
Sure.